Welcome back to Prep for Calc. Yesterday we, were we doing rational expressions still? Inverse proportions? No, but inverse variation, that would have been the day before. Logarithms, natural logarithm, exponentials, no. Fractions, no rational, solving rational, no. Something about rational expressions. Polynomial definition, monomial definition. I remember we gone over that. A monomial is basically a constant times a variable to a whole number power. And polynomial is a monomials, more than one monomial being added together. Monomial. Degree. Oh, okay, here we go. Polynomial long division. That's what we did. You're gonna put it in, so the degree of a polynomial is the degree of a monomial is basically the sum of the exponents or the variables exponents. The degree of a polynomial is the degree of the highest monomial. So polynomial long division, there's gonna be a remainder, and what you're gonna do is you put them in order. You know the division sign, put the polynomial under that. Outside of it, you're gonna put the divisor, and you're gonna have them in order of highest degree to lowest degree from left to right on both of them. Then you're gonna divide the first term by the first term of the divisor, and then you're gonna take the answer, put that on top of that division symbol. Then you're going to multiply that by the divisor and subtract that from the polynomial. Then you're going to get a new leading term for the polynomial side. Take that, divide it by the leading term of the divisor. Take that, put it on top, multiply it by the divisor, subtract what's remaining of the polynomial by that, and keep repeating that until you've got a degree of what used to be the polynomial, the numerator, that is less than the degree of the divisor. Rational expression is basically an algebraic expression that can be expressed as a polynomial divided by a polynomial, and a quadratic is a polynomial with a degree of 2. There might be some other thing I'm forgetting now. There is least common multiples of monomials. The reason I messed it up was because I accidentally did GCF, greatest common factor. Or multiple is basically if you say n times a equals b and n is an integer, then b is a multiple of a. So that's that. I'm gonna jump back in and continue learning, then I'll be back to recall what I learned in a little bit. All right, guys, we just ripped. This was the most topics we've gone through in a single day. I don't even know why half of these were marked as I don't know them when I didn't even have to read the thing and to get it right. So we finished up rational expressions yesterday. So today we started on my next weakest area, which was functions and graphs. Graphs and functions, which I was like, well, come on, functions and graphs. No way. Like, I know functions and graphs pretty well. What are we gonna get here? Well, first, okay, there were like 2 sections that I didn't know. I don't know if I've ever learned. So a relation is a set of ordered pairs. Okay, that's a nice definition to know. I actually never really learned that till earlier today, which is crazy that I learned it in the same day. Take a ChatGPT quiz on discrete math. Anyway, how do you define the domain and range of a relation? Well, the domain of a relation is going to be it's going to be a set of the first elements in the ordered pairs, and the range is going to be a set of the second elements in the ordered pairs of the relation. So that's the domain of a relation or a set of relations. So just something you got to know. And sets don't repeat themselves, so you don't. Each element's unique. I'll say that. I think it's unordered as well, but that's not really that relevant in this case, at least. So that's what a relation is. That's the domain of a relation. That's a range of a relation. Okay, next topic. Determining if relations are functions. This I didn't need to study or learn. I learned this last semester. This is basically the vertical line test on a graph, or is looking at inputs and making sure that every input has only exactly one output. If it has more than one output, not a function. It's a relation that's not a function. There you go. That's simple as that. Next topic. Maybe I'm forgetting one, but one of the topics I remember here is what was it? Evaluating absolute value functions, functions with radicals, absolute values, and square roots. Maybe evaluating functions with square roots, absolute values, and I can't remember the third, but evaluating, meaning you're saying f of x equals as a function, then you're plugging in an input for x. Boom, plug that in, there you go. So didn't need to learn that. I knew how to plug in x and solve for absolute value, or simplify absolute values, or square roots, and something else. Here we go, I'm gonna look really quick. Rational expressions. Then the next topic was transforming a graph by reflecting over an axis. Why do they assume I don't know this? I didn't get tested on that at all. I would have got that right. Right, like if the function's negative, you're gonna reflect it over the x-axis. If the input is negated, you're gonna flip over the y-axis or reflect over the y-axis. I believe. I didn't take any notes on that, but I can figure it out pretty easily. Okay, one more thing. Intersections and unions of a finite function. This is simple again. I would have got this right. I don't know why they're assuming I don't know how to do this. If a union, you've got two sets. It's all the unique elements from both of them if you combine them. And intersection is only the elements that are in both sets. Meaning ABC, CD, E, then C is the intersection. It's the one that's the same in both, or it's in both. It's like a Venn diagram. It's the thing in the middle. A union is basically the whole thing. It's as long as it's a set, so the elements don't repeat. But if it's in A, B, or in both, it's in the union. And a little circle with a cross through it, that's how you denote it. An empty set. Okay. All right, that's it for today. We're probably close to finishing the first pass of all the topics I can, at least at this point. And after that, we're just going to go and rip through the rest of them. Most of them I should just need to answer one more question correctly and will be topic learned. So that's it for today. Talk to you tomorrow. See you.